Alright, I just completely failed my first attempt at making this video, so I'll make it again. Alright, the time I started is 2:30 now. Alright. So the problem asks, this is FRQ Set 3, number 3, by the way. A 20 kilogram mass released from rest slides 6 meters down a frictionless plane inclined at a meter angle of 3 degrees with the horizontal attractive spring. Alright, basically there's K, there's distance, and there's an angle, and a block bounces on the string and compresses it. That's pretty much it. Alright, part A. Determine the speed of the block just before it hits the spring, which means determine the speed after it has traveled the 6 meters here. Alright, so we'll use conservation of energy here. PE equals KE. Okay, PE equals mass times gravity times height, and KE equals 1/2 times mass times velocity squared. Okay, since both sides have m's, we can cancel them out. G is 9.8, and H, we can find it by using trigonometry. So the block has traveled down 6 meters, and to find the height, we can use the 30 degrees and set up the equation sine 30 equals opposite over hypotenuse. Now the opposite is of 30 degrees is h, and the hypotenuse of the triangle is 6 meters. So sine 30 equals h over 6. And to isolate for h, you multiply 6 to the other side to get h equals 6 sine 30, which is equal to 3 meters. Alright, so h equals 3. Okay, next we can move 1/2 to the other side by multiplying both sides by 2. And in the end, we get 58.8 equals v squared. And when you square both sides, you get v equals 7.67 meters per second. Alright. Now, part B. Calculate the time it takes for the mass to travel the 6 meters. Alright. Well, that's really easy. So we know that the only force acting on the block during this time is F of G. And then since the block is moving in this direction, we have to find F of G of X, which is right here. Let me make that dotted just to satisfy you. Like this. FGX. Okay, and FGX equals FG sine of 30. Nah, you don't need to know that. Anyway, so we know that that's the only force, which means from here to the 6 meters, acceleration is constant, which means we can use the formula V average equals VF plus VI over 2. And V average is also equal to delta X over delta T equals VF plus VI over 2. So what we can do is, here we go, isolate for T. So delta X equals VF plus VI over 2 times T, and then divide this whole thing to the other side. So we end up getting 2 delta X over VF plus VI equals delta T. Okay. 2 delta X, distance traveled is 6. VF, as we saw in part A, is 7.67 meters per second squared. And since the block starts at rest, VI is 0. And that would equal delta T. Calculate that, and we get delta T equals 1.56 seconds. Okay. Okay, next up, part C. Part C says, determine the distance the spring has been compressed when the block comes to rest. So, when the block comes to rest, there is no kinetic energy, and there's only potential energy from the spring at the end. So if we start at the top, we can set up PE again equals PE spring when the block comes to rest after compressing the spring. So P once again is mgh, and PE spring is 1/2 K X squared. So K is 200 newtons divided by over meters. Okay. So mass is 20 kilograms. G is 9.8, and h. Alright, so here's the spring. I'll draw a little picture to show you. And here's the block. So the block travels 6 meters. This is 6 meters. But also, once the spring is compressed, it has also traveled x meters, the same x as this one, because x shows how much the spring has been compressed. So which means, to find the height, assuming this is the ground, we set this to the ground, height equals 6 plus x sine 30. So sine 30 equals h over 6 plus x, which means h equals 6 plus x sine 30. Like this. So that will be our h. 6 plus x sine 30 equals, I'm out of room, but whatever, 1/2. K is 200 x squared. Hope you can still see that. Alright, so when we calculate 20 times 9.8 times sine 30, we get 98 times 6 plus x equals 1/2 times 200 is 100 x squared. Okay, we distribute the 98 to get 588 plus 98x equals 100x squared. So now we can set up a quadratic equation by moving 98x and 588 to the other side. So we get 100x squared minus 98x minus 588 equals 0. And by doing the quadratic formula, we end up getting x equals 2.96 meters, which means the spring has compressed this much once the block finally stops. Next, part D. Part D says, is the speed of the block a maximum at the instant the block strikes the spring? Justify your answer. Alright, so the maximum speed occurs right before the block begins to decelerate. And the block begins to decelerate when f of spring equals fgx. So to prove that, we'll take delta f equals ma. When the block touches the spring, there are two forces now, fgx and f of spring pushing against it equals 20. And since the block is at a maximum when a equals 0, because that is just before the block loses speed when it decelerates, it will be equal to 0. So we can cross that out, we can move f spring to the other side, and we get fgx equals f spring. I just wanted to prove that. Alright, so fgx is fg sine 30, which is also equal to mg sine 30. And f of spring equals negative kx. Okay, so mass is 20, g is 9.8, and sine 30. K is 200, x. Okay, 20 times 9.8 times sine 30, we actually did that before, equals 98, equals negative 200x. Divide 200 over, and we get x equals negative 0.49 meters. So what this means is the block is at its maximum speed when the spring has been compressed 0.49 meters, because that is when acceleration is 0 at that point. Okay. Part E. Alright, part E is pretty long. So part E says the mass is now 40 kilograms, and we're supposed to redo part A, part B, and part C to see if there's any change in answer with this new mass. Okay, so part A. Part A we did. Potential energy equals kinetic energy. mgh equals 1/2 mv squared. So as we see here, the mass cancels out, which means this problem does not rely on mass, which means no matter what the mass is, the answer never changes. So V will still be 7.67 meters per second squared. So part B, determine the time it takes. So we have delta x or delta t No, actually, I'll just copy the isolation for t from part B before. So delta t equals 2 delta x equals Vf plus Vi. So everything is still the same. Delta x is still 6, and Vf from part A is still 7.67, Vi is still 0, which means delta t is still 1.56 seconds. Because the final velocity did not change, time does not change either. And now part C. Determine the distance the spring has been compressed when the block comes to rest. Okay, so we had PEI equals PE spring, MGH equals 1/2 kx squared. Okay, so we have mass is 40, G is 9.8, and H is 6 plus x sine 30, as figured out before, equals 1/2 200 x squared. Okay, so this 40 times 9.8 times sine 30 is 196. Okay, 6 plus x equals 100 x squared. So we distribute that and we get 1176 plus 196x equals 100x squared. And same thing as before, we do quadratic equation. 100x squared minus 196x minus 1176 equals 0. And we end up getting x equals 4.55 meters. So unlike part A and B, part C does change because we have mass here. It does not